Hello. So my name is Valerie, and I wanted to talk to you about cancer, but not just the usual way people usually talk about cancer. It's a little bit of a twist on it. So first I wanted to ask you guys, if I say cancer, what do you think of? Could you shout out something?
Tumor.
Something bad, tumor, death. Things that have to do with like the disease and biology maybe. Oncogenes, that's definitely a biology word. I work on the physics of cancer, which is maybe a little bit confusing because like, what does physics have to do with cancer? So I want to try and convince you in my words and maybe 2 songs why it might be important. So one thing to know about cancer is that basically what happens is you have a tumor, which is a bunch of cells that are growing when they shouldn't be growing. So they start like getting bigger and bigger and bigger. And for me, I'm getting bigger now, it's fine, I have the space to do that. But if I'm in a body, there's tissue around me, and I start pushing on the tissue next to me. And that's not good for that healthy tissue next to me because they get put under stress. They're being pushed on, they don't like when that happens. And they start activating something called a signaling pathway, which is basically making molecules. And one of the molecules they make, it's called beta-catenin, but you really don't have to remember that. Having a lot of this protein is actually something that cancer cells also do. So basically, these healthy cells start acting more like cancer cells because they're being pushed on by cancer cells. And you might think, how do you know it's because they're being pushed on? Isn't it just like a chemical signal that the cancer cells are giving? Researchers can be very, very smart. Well, you'd hope so. They tested this by putting magnets in mice, the model they were using, and used these magnets to put a pressure on these healthy cells, and they did the same thing. They started acting more like a cancer cell. So when I was thinking about one of those healthy cells sitting right next to one of those tumor cells and being pushed on constantly, I felt really bad for it, and I thought maybe I'll write a song about it, because that's what I do. So I really apologize for my singing. You can try and get out, but I don't think you'll be able to. Hello there, I am a cell, feeling healthy, fit and well. And I always forget the chords. Oh, I'm so sorry. I will start again and do better. Hello there, I am a cell, feeling healthy, fit and well. Life is good, oh life is swell, but my neighbor's got it worse. Something about him is just wrong, the way he pushes just feels wrong. They say in him the force is strong, they say he's got the force. He takes up so much space and is always getting in my face. It puts me in a stressful place. You can say he's left his mark. It's like swimming with a shark. He's pushing me towards the dark side of the force. The dark side of the force. I don't know if you can tell, I'm also a Star Wars fan. So that's one example of how physics and cancer actually are quite important together. And I'll give you another example. And this has to do with properties that tissue have in your body. So tissue has physical properties. It can have what we'll call like a shape or a size, and also what I'll call mechanical properties. It can be something, tissue can be soft and squishy, and tissue can be stiff. I shouldn't be saying this in front of teenagers. I mean like tissue. Never mind. Anyway, so cells in tissue can be soft and squishy, or they can be stiff. And these are things that change during cancer progression. So, for example, a cancer cell, and especially aggressive cancers, they're a lot softer than healthy tissue. And this is useful for a cancer cell, especially an aggressive one, because cancer likes to spread to other parts of the body. And when you're soft and squishy, you can squeeze through other cells. You can squeeze into the bloodstream and get to other parts of the body. And knowing that cancer cells have this other property, that they're softer, is really useful for researchers, because we can then test different cells, see how soft they are, and predict if it's going to be an aggressive cancer or not, and treat accordingly. In terms of tissue, actually tumor tissue is stiffer than healthy tissue, and this is because, I know it's really confusing, I just said the cells are softer, how can the tissue be stiffer? There's also something sitting in between the cells, and this is called the extracellular matrix. You can imagine it being like like a scaffold for a building to make sure that everything sits in the right place and things don't collapse. And with the tumor, the scaffold has been built really, really quickly. So someone just like threw a big pile of sticks and stuff on a heap, and that makes the tissue stiffer. And for people, it's actually quite convenient because it means you can try and feel for lumps, which for women, it's like feeling for breast lumps. I don't know, all made you look that way, sorry for that. So basically, this is a very useful thing to know because researchers can use this fact to diagnose cancer, see if it is aggressive cancer or not, and treat, and we can treat things better. Obviously, I wrote a song about that as well. So here we go again. You know cancer's about biology and add a bit of chemistry, but I'm telling you there's physics too. Yes, physics is happening inside you. Just with just one subject we can never be sure. Put them together and we might find a cure. And what a wonderful world that would be. So what I personally did is I was actually looking for techniques to be able to measure these mechanical properties so that we can do these things earlier, so detect cancer earlier and treat it better, and also see what mechanical forces have to do, how it influences behavior of a cell. And this involved me going to work in a lab with a lot of complicated things like lasers and acoustic instruments and cords lying over the ground. And I'm a very clumsy person, so it's not a good idea to put me in a lab. So, but I did survive 4 years later, and I'm still standing here magically. So I have one last song for you, and I was hoping you can help me out and sing along with the chorus. It's really easy. You just sing dumb ways to die a lot of times. So I'll sing that part for you first, and then you'll know it, and you can sing along when I sing it in the song. Okay, so I want you to sing dumb ways to die, so many dumb ways to die. And then the second time along it goes, dumb ways to die, so many dumb ways to die. People seem to know it already, because I took it from like an ad or something. I did not write the tune myself. Okay, so when I sing that bit, you can all sing along. And if you've guessed correctly, these are things you should not do. Shine a laser in your eye, eat a piece of bacterial contaminated pie, stick your hand in a supersonic bath, your head explodes from doing too much math. Dumb ways to die, so many dumb ways to die. Dumb ways to die, so many dumb ways to die. Trip over an electrical cord, accidentally open a toxic lab door, switch your drinking water for some chemicals, use that laser light to shave your balls. Dumb ways to die, so many dumb ways to die. Dumb ways to die, so many dumb ways to die. Prick yourself with a syringe, get bitten by a mice with an eating binge, expose your skin to UV light, try telling your supervisor you think they're not right. Dumb ways to die, so many dumb ways to die. Dumb ways to die, so many dumb ways to die. Thank you very much.